Okay, section 12.1, rules for exponents. Let's look at our objectives here. Okay, use the product rule for exponents, simplify expressions that contain the exponent 0, use the quotient rule for exponents, and simplify expressions that contain negative exponents. Okay, and of course I X'd out the graphing calculator because we won't be using that. Let's look at our rule here. Okay, product rule for exponents. If a is a non-zero real number and m and n are integers, then a with the power of n times n to the power of n equals a n plus n. Okay, notice we just have same bases and we can add the powers, and that's what it says right here. So let's continue on. Also, a reminder about the exponent 1. If a variable or constant has no exponent written, the exponent is understood to be 1. For example, y equals y1 and 7 equals 7 to the power of 1. Okay, so this will become very important as we kind of move forward. You'll see why. Okay, use the product rule for exponents to simplify the following expressions. Okay, let's just kind of work our way through these. Get a pen out. Okay, notice we've got x squared times x to the 4th. Okay, well, if I come in here and notice we have the same bases, that's the same thing as saying x2 plus 4, which when we evaluate that, you get x to the 6th. Okay, looking also here, okay, we have a times b to the power of 6. Well, notice they do not have different bases. They have different bases, so we can still multiply those together, but we're just going to get a b to the power of 6. Let's continue on. Okay, we've got 4 squared times 4. Well, notice that's going to be, we got same bases here, so that's going to be 4 times, and I got a power of 2 plus, right here I have a power of 1. Okay, well, that's going to be the same thing as saying 4 to the cubed, and that's going to end up equaling 64. Okay, once again, I've got two bases that are the same, so I'm going to just write those down. Now I've got two powers. Well, that's going to be 3 plus 2. Well, that's going to end up being 2 to the power of 5. And we evaluate that, we're going to get 32. Okay? And let's do this last one here. Notice that even though these are in parentheses and they're negatives, they are still the same base. So we can still go ahead and write this as negative 2. I'm going to keep the parenthesis. Well, I've got to the power of 4. And I've got 1 to the power of 3. So it's going to be 4 plus 3. Okay, all that's going to equal negative 2. Go ahead and keep that in parentheses. It's actually very important to keep that in parentheses. To the power of 7. And when we evaluate that, we get negative 128. Okay, and we should have known that because, of course, since we had a odd number here, that would automatically give us a negative. So let's continue on. Let's look at another rule definition here. Okay. The exponent 0. Definition. If a is a non-zero real number, then a to the power of 0 always equals 1. Okay? And then the expression 0 to the power of 0 is undefined. Okay, let's continue on. We'll do a couple examples of these. Pretty straightforward, because what did it just say? 10 to the power of 0. Well, everything to the power of 0 is just 1. Okay? Well, if we continue on looking at the next one, okay, we got a to the power of 0 times 10 to the power of 3. Well, notice here I kept this in here. That's 0 plus 3 because that's just going to be a 1 there. So that's like saying 1 times this. Well, this is just going to evaluate to x to the power of 3. And then we've got negative 6 to the power of 0. Same rule applies. Everything to the power of 0 is just 1. So don't let them fool you. Okay? Now let's do probably the harder one of all these. And remember, all these are eventually going to probably get kind of combined into certain things, so just kind of be aware of that. Okay, the quotient rule. If a is a non-zero real number and m and n are integers, then a to the power n divided by a to the power n is just a n minus n. Okay, basically you're just taking these and you're subtracting, but remember this formula. Okay, you have to use this formula every single time. Okay, eventually we're going to have things called negative exponents. You're going to, but remember, we don't change the formula. So let's take a look here. We got two of them here. So I've got, remember, a to the power of 6 and then x. Well, remember that x is power of the 1. So that is the same thing as saying x 6 minus 1, okay? And that is going to equal x to the 5th. And notice what happens is this guy reduces out. Okay, continuing on, I've got y to the power of 8 divided by y to the power of 2, or y squared. Well, that's the same thing as writing y to the power of 8 minus 2, and that's just going to be y to the power of 6. Okay, and that would just cancel out on the bottom. Let's continue on, do a few more examples. Okay, notice they're just a little bit harder now. We've got some other things going on, but the same rule still applies. Okay, but notice now what I'm going to do is I'm just going to start reducing out by, I'm not going to start just taking the fraction away like I did before. So notice here we can reduce this 15 over 3. Well, we know that 15 over 3, we can divide everything by 3, and that's going to give us 5 thirds. Okay, I've got this x to the power x cubed here, and I got x to the 15th there. So that's going to be x 15 minus 3. Just going to draw my line a little bit further there. Okay, and that's going to give me, keep the 5. Okay, draw a little line here, keep the third on the bottom, and that's going to give me x to the power of 12. Okay, and that would be my final answer for that one. Let's do the last one here. Well, I've got 20 x to the 10th y to the 6th all over 2x squared y cubed. Okay, well, notice that we can go ahead and reduce this down. I'll put it right down here. Okay, this is going to reduce to 10. Okay, and let's look at this x here, and notice I have a 2 on the bottom and I have a 10 here, so it's going to be x 10 minus 2, and then we're going to have y 6 minus 3 all over. I'm going to have this 2 left on the bottom, and instead of a 2, remember, it's going to reduce down to a 1. So for right now, I'm going to put this 1 here, but notice I'm probably going to have to just keep that 1 there, and eventually it's just going to go away. But right now, just for the sake of clarity, I want to go through step by step. So continuing on, I'm going to have 10 x to the 8, because I have this 10 minus 2, y to the third all over 1, which is going to end up equaling 10 x to the 8 y to the third, and we can go. That's when we can kind of write it without the 1. Okay, rule for negative exponents. If a is a non-zero number and n is an integer, then a to the negative n equals 1 over a to the n. I want to continue this one on though, because what you will eventually see is this right here. You could also have this. What if you had 1 all over a to the negative n, and it was already down here? Well, that would just flow back to a to the n. Okay, so notice this can go back and forth, okay, depending on where that negative is. Basically, it's saying if you have a negative exponent, it's either going to become a fraction or it gets rid of a fraction. So I kind of want to throw that out there. Let's do some examples here. So we've got 5 to the negative 1, okay? Well, remember, that negative 1 is connected to that 5. So let's just come in here and go, well, since that's a negative power, that's going to be the same thing as saying 1/5. Okay? Well, same thing here. X to the negative third. Same rule applies. Since I'm going to have this, I'm going to drop this down, okay, and just have 1x to the third. And notice we're dropping the parenthesis at that point. And let's do our last one here. And here's what I was talking about, how we can combine rules. If you remember the first thing we learned using the product rule for exponents, since we have the same bases, this is the same thing as saying x negative 9 plus 7. Well, we know that negative 9 plus 7 is still going to give us x to the negative 2. And now, using our new property of negative exponents, we know that this is going to be the same thing as saying x 1 over x squared. Okay? So don't get confused if you start seeing negatives just pop up. The same rules apply. Okay? Don't get too worried about things like all of a sudden getting messed up. The same rules of math usually carry forward. Okay, there's nothing wrong with negative exponents. I just kind of threw this in there. It's also going to be in your PDFs, especially in calculus. You're going to love negative exponents, okay, because we don't really like exponents on the bottom a lot. Okay, let's continue on with just some notes here. Using the quotient rule, regardless of the size of the exponents or whether they are positive or negative, the following single subtraction rule can be used with the quotient rule. Numerator minus exponent. Okay, the subtraction will always lead to the correct answer. What they're saying here, I'll do an example. Let's say we have x to the power of 6 all over x to the power of 7. Okay, notice this is larger. Well, you're still going to use the same rule of 6 minus 7, which is going to give us x to the negative 1, which is going to give us 1 over x. Okay, that still leads to the correct answer, so be ready for that. Okay, and then just right here, just a little listing of your some rules. I would suggest printing this out, maybe just going through it, kind of, I wouldn't say memorize it, because most of these you're just going to just kind of learn over time, and once you do them enough, they just kind of become muscle memory. But it might be good, it's something to look at for about 20-30 seconds every day. Maybe get up, take a look at it, and then just move on with your day. All right, let's do some examples.